Hello, Space Cadets, and welcome to Mueller Planetarium Astronomy at Home. This is Zach Thompson, Planetarium Coordinator at the University of Nebraska State Museum at Morrill Hall in Lincoln, Nebraska, wishing you all clear skies. Today we're going to explore the seasons, especially summer, because that's right around the corner. We're going to use our friend Stellarium. Look to the right of your screen, you'll find the web address stellarium.org being held up by our Earth buddy. That way you can download the software on your computer at home and follow along with us. To understand the seasons, we first need to get a good idea of how the Earth orbits the Sun. Let's use this helpful image from our friends at NASA, and it shows you the 4 seasons. The reason for those seasons is because of the Earth's tilt. We are tilted 23.5 degrees. You'll notice to the left of your screen where you see summer that there is a portion of the Earth that is tilted towards the Sun and a portion that's tilted away. And again, that makes all the difference. In the northern hemisphere for summer, we are receiving the most direct sunlight. At the same time, on the other end of the globe, the southern hemisphere, they are tilted away from the sun, so they aren't getting as much direct sunlight. That's why it's cooler during that time of the year for them. However, there are 2 seasons, spring and fall, that we call the equinoxes, where both the northern and southern hemisphere experience roughly the same amount of sunlight. And that's why they get the name, in fact, equinoxes, equal. Those things are equal. So here's just kind of a broad image of that. Let's explore what that might appear like to us here on Earth. Again, we are here in Lincoln, Nebraska. That's the location we're using. But depending on where you happen to be viewing this from, you would change that in Stellarium because your location will affect how you experience the seasons. So for Lincoln, Nebraska, we see we are situated here for Saturday, June 20th, because that is when the first day of summer officially begins in the northern hemisphere, astronomical summer. The Earth rises in the east roughly, and it sets in the west, and throughout the day, the sun rides along on this imaginary line called the ecliptic. At some point in the day, the ecliptic meets what's called the meridian. It's this line that cuts the sky in half, and it runs north to south. That's the meridian, also called the observer's meridian. When the sun on the ecliptic meets the meridian, this is what we would say is midday. So the sun, during the morning hours, is rising to meet the meridian. It meets it, which is the highest point in the day. And after that, the sun then moves away from the meridian, and it starts to head towards sunset. One more line to introduce is called the celestial equator. If you remember from our Polaris video, the celestial equator is just like the regular equator, only it's celestial. No, it's just extending our equator outward pretty much forever into space on something called the celestial sphere. And then we also have a north and south celestial pole. So when you see this equator here, it's referring to the celestial equator. Notice here, again, we are on the day of Saturday, June 20th of 2020. That is the summer solstice in the northern hemisphere. That is when the sun is above the celestial equator. So this is the longest day because this is the highest point on the meridian that the sun is going to reach in the northern hemisphere. We are receiving the most direct sunlight. And you also, of course, have the shortest night. This is why going, for example, from spring to summer, the days tend to get hotter. The weather temperature tends to get hotter because the more direct sunlight is warming things up. As we then move forward in time, we go ahead 3 more months into September. And here is when the sun, when it reaches the meridian, also meets the celestial equator. And this, since we're in September here, would be the autumnal equinox. We are not getting as much direct sunlight as we did in the summer, but we have roughly equal amounts of day and night. And then, of course, because we had less direct sunlight, it got a little bit cooler out, going from summer. But the sun keeps traveling in the sky, lower and lower, until it reaches the lowest point that it's ever going to reach when it strikes the meridian. The meridian is the key for all of this here. When the sun meets the meridian at its lowest point here in December, what season is that? Well, that would be the winter solstice, the winter season. Again, this is all in the northern hemisphere. Therefore, we have the least amount of direct sunlight. It's much colder. Things don't heat up as much. And on the winter solstice, there is the longest night or the shortest day. From that point, the sun starts to rise higher and higher until finally spring comes back. Spring is here again. And we have the vernal equinox, which is, again, the same thing as spring. Notice here, though, what's the same that you just saw, that you are looking at right now with spring? Well, it's where the sun is meeting the celestial equator again. And that means you're getting just as much daylight as you did during the fall. Hence, equinoxes. Equal amounts of direct sunlight, equal day and night. And things at this point are warming up, and they get warmer and warmer because there, the sun is at its highest point in the sky. It's above the celestial equator again, and we are back to summer. Things are nice and hot. So this is just kind of a really rough overview of understanding the path the sun seems to take in the sky. And we didn't just discover this. This has been known for a long time. People long before us were excellent observers, and they devised these imaginary lines to really grasp what was changing. And the reason the sun moves that way, the reason the sun moves from high to middle to low, all comes back to this. It comes back to this image, the tilt of the Earth. It is all thanks to that. The seasons, the difference of them has nothing to do with the Earth itself being closer or farther away from the sun. That is completely irrelevant to the overall understanding of the seasons. Tilt is everything. Now, if you've got any questions, Space Cadets, about this or something you saw or you might have heard here, we're happy to help you. Please leave questions or comments in the section below. Above all else, remember to go outside and keep looking up. Enjoy summer, everybody.